In this video, we're going to be looking at a couple application problems for inverse functions. So we'll start with the first one. George finds the total amount of time it takes him to drive from his house to the highway, then to somewhere d miles away, can be modeled using the equation t equals 0.92d plus 5, where t is time in minutes. Now in the current version of this equation, t is our output and d is the input. But what if we want to find a function that instead modeled distance as a function of time? In other words, switched the input and output. Well, that's exactly what an inverse function does. Now, when we're doing application problems, we're not going to switch the variables anymore because it would get confusing as to which variable meant what. But what we will do is just solve for d. So that's all we have to do. We're going to be solving our equation for distance. So in order to do that, the first thing we want to do is subtract 5 from both sides, which will leave us with t minus 5 equals 0.92d. And then to get d completely alone, we will have to divide both sides by 0.92, which will leave us with the equation d equals t minus 5 divided by 0.92. So now we have an equation that tells us distance if we have a time as an input, which lets us answer questions like how far can George drive if he has 35 minutes to get there? So all we have to do now is use our new equation and plug in 35 minutes for t. If we put that in our calculator really quickly, we can find that the distance here that George can drive in 35 minutes will be 32.6 miles. In our second example, we're going to have to make up the function ourselves. So the cake store your friend works at charges a $6 fee for putting custom writing on a cake. There is also a 6% sales tax charged on top of that. So we want to write a function, first of all, that models the total cost of a custom cake, including tax, as a function of the original price. Well, let's call total cost C, and let's call the original price P. So in order to find what the total cost of this cake is, we're going to have to, first of all, take whatever the original price was, and then add on this custom cake fee of $6. Now, in order to do tax, we're going to have to add that 6% on top. Well, 6% as a decimal is 0.06. So in order to kind of add an additional 0.06 on top of this, we'll have to multiply it by 1.06. So this will now give us the total cost of a cake for any original price P. So if we want to now find the other direction, right, if we want to find out the original price, if we know the total cost, then that means we have to solve this equation for P, which is essentially finding the inverse function, right, the function that undoes the one we wrote up there. So the first thing we have to do is divide by 1.06. So then we would get C divided by 1.06 equals P plus 6. And finally, we have to subtract 6 from both sides. So P is equal to C divided by 1.06 minus 6. So this equation will tell you what the original price, P, of the cake was if the total cost was C, which lets us answer questions like, what was the original price of a cake if the total cost on your receipt was $30.74. So all I have to do to solve this is plug in $30.74 for C into our inverse function that we made up. And I believe in the end, after do all of that math out, P should come out to be $23.